So I have marked your the test tool, and then I have uploaded the results, the grades in the spectrums under the section continuous assessment. Okay. So you can be checked what is your grades they fall in. Okay. But for your information, some of you get the grade is a B. In fact, your grade will be near the marks of the A. Okay. So let us go through the here. Okay. So in the second test, in fact, I'm testing you all on the confounding and the fractional analysis. Okay, or the fractional 2 power k design. So the first in the first question, I have mentioned to you here we are doing for the what are the factor will be confounded with the blocks. Okay, so we have two blocks here. The one is for the litters ones, another one is for the litters twos, where this one is the first replicate and the second replicates. So they are do the confounding about this one. Suppose for the every of the blocks, we should be runs the all the treatment combination. Because of the limited resources, then an incomplete block design will be used, where for each block we only run for the 4 treatment combination. Another block will run for the treatment combination, and then inside here we consist of the 2 different replicates here. Okay, so from the first replicate, I will ask you which treatment are confounded with the blocks. So the first block. Okay, about the first block, then you need to check the sign of the treatment combination. Then, if those of the same sign, they belong to the same the same category, and then the second one will be belong to another sign. So that one is considered as that particular treatment combination will combine it with the blocks. So if those of the students, this one is a majority of students were able to do it, where you will get the BC will confounded for the first replicate, where else the second one will be the AC will confounded for the second replicates. So the question number A is just this one is the answer for the question number A here. Okay, then after that, I ask you to, based on the information here, you go to estimate your effects, the main effects. But some students, they gave me all the iterations effects. So you spend a lot of times on counting all these iterations effects. Okay, because the idea is just want you to know how to calculate the mean effects. So inside this experiment, they consist of the 3 factors. So therefore, I will ask you just calculate the effect of the A, B, and the C. That's all. Okay. So instead of you are doing the calculation of all these things. Okay. So I want to make sure that you know how to, from the information here, how do you get out the effects here. This one is most of the students will be also able to do that, able to get it. Okay. Then against the third one, I ask you to just form the analysis of variance table, including the sum of square, degree of freedom, and the mean square. Hence, propose a test for all the effects without perform any calculation. So maybe some students also, you spend your time to do the calculation of the sum of square. Okay, so I have just asked you is just form the ANOVA table. So in your ANOVA table, okay, this one will be the factors. Okay, you have many of the different factors. You have A, B, C. After that, you have A, B, and so on until the blocks replicates. So you need to list down all the factors is involved here. And then after that, you need to have a sum of square. So I just ask you a sum of square. So to this one, you just write this SSA is enough. Okay, but because you are doing the confounding of the BC is in the first replicate. So therefore, for the BC here, your sum of square, you need to write it clearly. The sum of square for the BC, you can, in fact, when you do the confounding, they cannot obtain the BC. But because you are confounding the BC in the first replicate, therefore the sum of square for the BC can be obtained from the second replicate. Okay, so these are the things is where we'll expect from you all about the ANOVA tables. Then after that, of course, the following one will be the degree of freedom. And then the following one will be the mean square. And then the last one will be the F-test. Okay, so your F-test also is another thing. When you have a degree of freedom is 1, the mean square will be the MSA. Okay, then of course you have errors, you have errors, you have a blocks. You also have another one is a replicates. Okay, so to test for the MSA, you should be using the MS for the A over MS for the E. Okay, so in your ANOVA table should be consist of all these factors together with the errors so that you can be tested it, and then the MS for the blocks. You are not interested about the blocks because the block is some sort of like the Nelson factors. So you are not interested, but some student it just tested the block. Okay, in fact, you study all these things because you are having the different blocks. Therefore, you're using the confounding techniques to do that. If you are able to run the complete set, then you do not have any Nelson factor, then you no need to consider the blocks there. Okay, but in your study of the design experiment, always you need to care about it is just your factors. You have a main factors, you have 2-factor iteration. This one is your main target. Okay, you want to know that whether this factor will be significant or they are not the significant. Okay, so this one is for the first question. It's just understanding about this one. About here, the calculation, then you need to calculate over here. Okay, so this one is for the first question. Okay, and then for the second question, this one is for the fractional 2 power of k design. Okay, so I also will tell you very clearly, this one is a fractional where it's a 2 power of 4 minus 1 fractional, and then you're using the following defining relationship I equal to ABCD as the defining relation of the here. Okay, so these are the results they obtain here. So the question number A here, how do you how the plus minus sign will determine for the factor of the D? So what you can do is just a D equal just you have a I will equal to A, B, C, D. So the D will equal to the ABC. So you check the sign of the D. Is it the D is a product of ABC? If yes, then this one is already D is a. You can show that the plus all the plus minus sign will be together. Okay, so this one is just a 1 marks here. Whatever you write it here, make sure that you clear. And then the second one is I ask you what is a restoration under this case. Okay, so the restoration, this thing you need to see about the words of here. Okay, another possibility is you look at the layer structure, then you can be explain it what is the restoration for this design. Okay, so the explanation, this definition I also have given you in the lecture notes. Okay, so for this case will be the restoration form. I think almost all the students should be can get it the restoration form. But you explain about what is a restoration form. It means that no main effect is alias with any of the main effect or any of the 2-factor iteration. Okay, but the 2-factor iteration are alias with each other. Okay, so this one is you explain it briefly. What is meaning by the restoration of this suggested design? Then after that, you form the alias structure here. Because you have given this one the defining relation, so you can find the alias structure for all of them. I give you the example for first one is the A will equal to you have this thing, you equal to B, C, D. After that, you have B will equal to multiply B here, multiply B here, you get the ACD. Okay, then after that, you have C will equal to the A, B, D. Okay, of course, you also have a D will equal to the ABC. So this one here. Then after that, you have a AB. AB here or AB here will equal to CD. Okay, and after that, you have a AC and so on. Okay, AC will be equal to the BD. Then after that, you have AD. A times D will equal to BC. Okay, so these are the alliance structure. Okay, this one will be tell you that what is the alliance structure so that you will be answer your part number D here. Okay, so I just ask you to list down what are the alliance structure of here. Then it's followed by what must we assume to estimate main effect and the two-factor iteration of AD, BD, and the CD. So what we are interested is about here. Then AD, I will interested about AD here. Interested of BD will be here. Interested of CD will be here. Okay. So what are you going to assume it? If the three-factor iteration of here is negligible, okay, all these three-factor iteration are negligible, as well as the AB, AC, and the BC are negligible. But some student, you are going to write, they have a three-factor iteration or higher order. Your higher order only have a three-factor iteration. You don't have the higher anymore. The three-factor iteration is a higher. So therefore, yeah, you still can get the marks for the three-factor iteration, but you put the higher, that one is you don't get any marks for the higher that part. Okay, so this one is what we have can assume if you want to estimate about here. But of course, if you don't want to assume, then you need to plot the normal probability plot. Then you only can be checked which factor are important, and then after that you only will assume. Okay. So this one is what you have in your part number D. Okay. So drawing the graph, I do not ask you to draw the graph inside here or in your final exam as well. Okay. After that, I want to make sure that you know how to perform the sum of the values. I have given you the complete values except these 4 cells. So you are from here, you calculate it back. Okay, so all these 4 values you recalculate again. But if you know the relationship of the effects and the sum of square, then you can from here directly calculate. Otherwise, you need to use the raw data. So I give you the 2 options. Either you want to use the raw data or you can be calculate from the effects here. From the effects here, you recalculate back the contrast, and then from the contrast square, then divided by the number of them, then you get your sum of square. Okay, so this part also majority of students is able to do that. Okay, so this one is regarding the test number 2. So for the test number 2, I have uploaded the results in the spectrum. Then later on you can be checking out. Okay, the test 2 I have putting in the continuous assessment. Then you can be check your the grade of the test 2. Okay. So this one is the first thing I will discuss you all. Okay, for the first part of here. Okay, so the similar thing I will ask you for the final examination. What I say the similar is means that I do not ask you to calculate the whole question from the 0. Means that from the all the effects you need to calculate out. I will give you parts of them. Then your calculation will be less is instead of all. Okay, so some explanation are required for your exam, for the final exam as well as the some calculation parts. Okay, like this type of question, I only able to ask you is just a definition and so on. Okay, you make sure that you understand about this thing. So this one is the first thing I will discuss you all about the test. If you have any question, you also can be asked me before the test, before the final exam. Okay. About the second thing is about the final exam date. Okay. Okay. The final exam dates and the assignment. So for your information, the test 1 and test 2 will contribute 20% as I stated in the early semester, the current course information. Okay, so you have a one group assignment is a 10% where you need to submit it end of this Friday. Okay, due on this Friday. And then after that, on the 9th of the February, you have the final examination. So the time will be starting from the 3 to the 6 o'clock. So I will upload the exam question to the Spectrum as well as the Microsoft Team. Then you download, you upload it back. One reminder to all the students is when you submit your exam question, make sure that you scan it properly. I have mentioned to you all, you can use a cam scanner in the smartphone apps. So your scan the process is clear because based on the test 1 and test 2, I found that some students just simply take the photo and then sometimes it's not clear. Okay, so far I still can see it, but I advise you all is make sure that you make it clear so that the examiner will see it clearly about what you have written. Okay, so your scanning process, either you use a scanner or you can be use apps to take the photo. At the same time, the photo will make it clear, then they convert it to the PDF format. Okay, so this one is I want to remind you all about your final exam. Okay, I believe that all the dates for the final examination have been released. You can go to our ISM website to go through it. Okay. So this one is the second thing. About the assignment, of course, the due date will be on the 28th of the year. Okay, on the Friday. Okay. Okay. So this one is a second reminder for all the students. The third one is about the course in for this course. Okay, so this one is all the structures I have discussed you all. So as a summary of this thing, I will put it here. Okay, so in this course, I believe that some students maybe they do not have any idea about the design experiment before they joining this course. Some students maybe they have took this course during their undergraduate study. So I assume that all the students maybe don't have any information. So when we go through for this course, the first thing is of course is the analysis of variance table. So I will introduce for you first what is meaning by the one-way ANOVA. Means that is only deal with the single factor. You have a study the single factor with the different levels. Okay. Then how do you use the analysis of variance to analyze it? Okay. Then in the analysis of variance, you partition all the sum of square to the each of the you partition the sum of square for total to the each of the sum of square. If you study the one-way ANOVA, you partition the sum of square for total to the sum of square for the treatment plus the sum of square for error. Then after that, you perform the test. The test is a test statistic is suitable is using the F test. Okay, so all these things is with the background. Then you will perform it the one-way ANOVA. Okay, then after you have performed the one-way ANOVA, I also introduce for you the multiple comparisons. After you know that the factors, for example, the factor A, they are significant different, then you want to know that which treatment combination or the which levels are significant or which level they are the same. So this one is where you go through the multiple comparison using the Tukey test and so on. Okay. Then after that, I also introduce for you what is means by the blocking. Okay, because later on you still need to learn the blocking and confounding. So therefore, I will introduce for you what is the blocking. So the blocking is a techniques. Okay, is a techniques to deal with the Nelson factors. So you have one Nelson factors or you have many Nelson factors. Okay, So you can use a Latin square design to deal with the two Nelson factors. Okay, so this one will be the introduction for this course. So once you get the idea, we will go to the what they call as a factorial design. Means that you involve the many factors. At the same time, their iteration you also consider in your analysis. For example, if you study the two factors, factor A and factor B, their iteration of the factor AB also you're going to analyze, because the iteration is significant, they will affect your result or your interpretation. So therefore, it's very important you want to know that the iteration are significant or not. But of course, when you deal with the many factors, for example, the 5 factors, then you have many terms of the iteration. So in that case, those of the higher order iteration, you can be ignore it due to the complicated of the design, or you want to know is just concentrate on the main effects or the main factors and the 2-factor iterations. Okay, so this one is about the factorial designs in general. Then after that, we will go to the one specific design. That one is called the 2 power of k factorial designs. Means that we only study the 2 levels with the k factors factorial design. This one, the 2 power of k factorial design, have a specialty in the sense that you can do it for the fractional and the blocking size. Okay. So the 2 power k factorial design also similar to the factorial design here. Then after that, under the 2 power k factorial design, you also study, you have k factors with the iterations factors also involved. Then you only study is the 2 levels. It's followed by you have a blocking there. Okay, the special case under the blocking, you can be doing similar to the previous. The idea is the same, is a blocking. So you have a Nelson factor, then you perform the blocking. But sometimes you cannot, for each block, you cannot run all the treatment combination. You only can run divided the treatment combination into the only run half of the 1/2 of the treatment combination. So in that case, for the each block, then you use the idea of the confounding, okay, to do the confounding here. So when you perform the confounding here, of course you will lose a certain information because you are unable to every block you run all the treatment combination. So of course you will lose certain information. Okay. So after the number 5 here, you go to number 6 here is a fractional 2 power k factorial design. So also the same thing, we do not want to run all the treatment combination. We want to run just a fraction of them. You can be the 1/2, 1/4, because we will expect that from the 1/2, you will obtain the similar information as the full factorial design. Of course, sometimes you will face a difficulty to get it. Therefore, you need to run another 1/2. Or if you want to run for the 1/4, you just run the 1/4. If you expect that from the 1/4, we can get the information, then we will proceed with our conclusion. If you do not have it, then you run another 1/4. So this one is called the fractional, under the fractional 2 power k factorial design. So under the fractional 2 power k design, you need to know what is means by the alliance structure, what is means by the restorations, what is the meaning by the defining relation, and so on. Okay. Then is followed by the fractional design. I will introduce for you the basic. Basic is a regression analysis. At least you know how to estimate the parameter of the regression analysis. So one of the regression model here will be applied it to the 2 power k factorial design, because we need to formulate out the equation. Okay, for the equation of with all the effects and the parameters. Then inside 2 power k factorial design under the regression, we also go through is what they call as a CCD, Center Composite Design. So that one will involve the S square terms, means that the quadratic term inside. So in that case also, you may need the regression models, the how to estimate the parameter. I have demonstrated to you in the tutorial question where we want to form the quadratic terms here. Okay, so I do not will go through in detail about regression model because the regression model is another of the course, but you need this basic idea so that you can be relate it to the factorial design here or the two power k factorial design to forming the equation. Then after that, the question, the number 8 here, I have gone through what is called the response surface methodology. How do you go towards the direction of the optimal solution? Then I have given you how do you form the equation of the linear regression model. They will still relate to the number 7. Then you form it out the equation and then towards the direction of the method of the steepener ascent or method of the steepener descent. Whether you go for the maximum or you go for the minimum. Okay. Then under the response surface methodology, I also have gone through with you about how to get the quadratic equations, and then from the quadratic equation, you can be identified whether this quadratic equation will lead you to the maximum response or the minimum response, or you only get the shader point here. Okay, so this one is covered in the response surface methodology. So after that, we will go through the last one is this one is called the robust design, or some of the books they use a robust parameter design. So this under this one, we were using the technique is called given by the Taguchi method. So under the Taguchi method, you are forming the treatment combination or the treatment combination in the table form of the cross array design, where your cross array design consists of the control variable and uncontrolled variables. Then how do you analyze it? You are using the signal to the noise ratio to analyze for the robust design. Okay, so I have given you the examples. How do you analyze for the robust design here? Okay, so this one is basically the full the course contains for this course. Okay, so about your final examination, okay, about your final examination, we will do it for all. Okay, we will do it for all of these things. Okay, of course, it's not the one-way ANOVA. They will be in the factorial design or the two power k factorial design onward. Okay, it's no longer as just one factor. Okay, so this one is what you need to go through it. Okay, all these things is you can be found in my lecture notes. Okay, because my lecture note is basically it come from the textbook, and then you also can be read more detail on the textbook because some of the parts I have simplified it. Okay, so this one is about the course content. Okay, so for your final exam will be cover all. Okay, if you excluded maybe this one, the one-way ANOVA, you can be excluded it. Okay, because blocking they may combine in the blocking and confounding. Okay, so even though you say that one-way ANOVA don't have the blocking, yes, they don't have the blocking here, but inside here you still have a blocking. Okay, so this one is the following one I'm going to tell you about this thing. Okay, so your exam should be on the 9. 9 is you still have a time to go through it. It's 9 is on the Wednesday. Today is the 26th. You still have a few weeks, 2 weeks to go through it. Okay. So this one is for the following one I want to discuss with you. Okay. Then the following one is I want to tell you is about how the exam question will be look like. Okay. Similar to what you have just now. Okay. The question will be some sort of similar to this thing. Where I given you the story, I will ask you to do it this one. But you bear in mind that this exam is a 3 hours exam. Okay, it's a 3-hour exam. So therefore, you you will involve the calculation as well as the explanation. Like this question, you need to know how to explain what is a restoration. You need to make it clear. Okay. So this one is one of the past year question. Okay, one of the past year question. Okay, the data set I have given to you is similar to like this list out the data set. For example, I will have given to you some information. Then I also given to you the some the all the effects here. So from here, you will make sure that you know how to compute for the effects and the sum of square. Okay, this thing is one of the examples. You can be see it. Okay, the question will be quite like if I given you a data set, then I will explain to you this data set I consist of the single replicate or the two replicates, and then some of the calculation I've given to you, then you just complete part of them. Okay, so this one is here. If the for the 2 power k design, we can be ask you is you can see that we can check the factors whether it's significant or not significant. We also can be check how to form the regression models. Then we also can be include the center point. How do you check the center point whether the quadratic term is necessary or not? Okay, so all these things will be covered in your final exam. Okay, all of the whatever I have discussed with you, I have given to you. Okay, I have given to you in the lecture notes. So some example also. This one is one of the example for the past year question. Also, this one will ask you about the 2 power the fractional design. So under the fractional design, I also have mentioned to you what is the defining relation. If I do not mention to you in your tutorial question, you also can be from the Bartholomew sign, you can be identified what is your defining relation. Okay, so all these things you need to have a two-way. Either the question is given, if they're not given, then you need to make sure that you know how to do it. Okay, all these things will appear in your tutorial question. I believe that in your tutorial you can see that how do you identify the defining relation. Okay. So under the fractional factorial design, of course, we will ask you, it definitely will be the layer structure. What is the restoration? Okay, so how do we estimate the certain factors? So as you can see, this is a partial question where I just ask you the theory part without the values. I do not ask you to recalculate all these values. Okay, so can be given the data, then you do the calculation, or without the data, you can be answer in the those of the understand the question without the calculation. Okay, and then beside this thing, beside this fractional design, beside the fractional design also, then we will proceed to the sum of the regression model. Like if I given you the certain fitted equation, then you can be directly find out whether this one is a maximum or the minimum problem. Okay, so this thing is I have to show it to you how to do the proving. Okay, the proving question I also have the how to prove the formula I also have given to you. Okay, so this one is what you need to aware about it. Okay, so about the just now we go back to the before I proceed it out about this question about the like if the question need the some calculation. So I will open for you all. You want to use a software to do the analysis also possible, or you want to do the manual calculation also possible. But both of them, if you are using the analysis software to do the analysis, make sure that you provide me those of the calculation. Like your test tool, some of them they're using the Excel to do the calculation. You just provide it. Otherwise, if I ask for you the answer, if you without all the working, then you just show me the final answer. Then how you expect me to give you the marks for the steps? So therefore, I unable to do it. For example, if you do the calculation, you just give me the answer, this one is 4.1, just an example. Then if this answer is wrong, you without showing any steps, so this part will definitely get the 0 marks. So therefore, I ask you, if you do the computer-based one, you make sure that you supply to me about your codes or your calculation, how do you calculate it? Okay, then at least the marks is awarded for the steps. Okay, otherwise you will get the 0 marks if you just supply me the values itself. Okay, so this one you need to take note. Okay, so you are free to use the any of the software to do that. Okay, the easiest way is you using the Excel. Okay, you no need to do any programming. Of course, I have shown it to you before that in the earlier semester how to use the R to do the calculation. But when you want to do the R, some of the command is not available. Then you need to do the programming. But this course is not deal with any of the programming. So therefore, I do not expect the student to spend the time to do the programming, to formulate the equations, even though you know the formula. Okay. So the question number 3 here is if I given the raw data, then you can estimate the parameter here. But that one will deal with the matrix. You will deal with the matrix. You estimate the parameter. You will need to deal x prime x inverse x prime y. You will need to deal with the following equation. So therefore, this thing is I won't be asked you to do this one in the class in the test here, because this one will deal with the big matrix. Okay, the dimension of the matrix is a huge. So therefore, I will given it to you if you're going to form the second order model. Okay, but of course the tutorial I have shown you the example. Tutorial question or assignment question is possible, but when you go for the final exam, it's less likely unless everybody has exposed to the certain software where you can do it calculation. So, but here I do not will ask you to calculate the high dimensional matrix. Okay. Then another one is will be this one is another examples is about the method of the signal action or method of signal descent. Okay, so this one is looking for the optimal solution. Okay, under the chapter of the response surface. Okay, so you can observe that in your final exam. Of course, the question may not be come out from the each chapter, one question, but they will combine it together. So you make sure that you understand about what you have learned previously. Okay, whatever I ask, those of the question is those of question is you are seen it before, you are able to answer one. Okay. Then the last one will be here will be this one is called the cross array design by using the Taguchi method, where you have an inner array and the outer array. So the information have given it to you. So under this section, the only thing is the technique is the only one is just a signal to the noise ratio. But of course, the signal to the noise ratio, you have 3 different criteria to consider, whether they want to have the larger the better or the maximum, or they want for the minimum, or they want to have the close to the target value. So all these things will be given by the question. Okay, for example, in this example, I was looking for the minimize. So means that you're looking for the smaller the better. So the signal to the noise, you're looking at the smaller the better. Then you after that you suggest what are the treatment combination or what are the factors. Okay, with their level should be chosen as the considered in the experiment. Okay, or what is their outcomes. Okay. So this one is basically I show it to you is because I want to link it to the here where all these things will be together. Okay, will be tested in the whole thing. Okay, so if you ask me which chapter will come out, in fact it's all. So your final examination will cover all. Okay, they are certain thing, for example, regression model, like the testing the quadratic effect, they will combine in the 2 power k factorial design. Or the blocking and the confounding is hidden in the 2 power of k together. Okay, so yeah, they basically will be the whole thing. So you just go through those of the notes you have. Okay, so this one is what I'm going to discuss with you today. Any of you have a question? First thing is about the assignment. You still have any question?
Yeah, doctor, I have a question for assignment.
Mm.
It's a group assignment so that one of the representatives submit to the spreadsheet.
Yeah. I think no need everybody submit. For the each group member or the leader is just submit is enough. No need all.
Okay.
Okay, but make sure that all of you keep the one record so that you know what are you doing. You have a discussion among your groups. Okay, if you want to put in, you want to submit also can, but for I just download the only for the as long as all the groups I have given the groups here, so I make sure that all the groups have a assignment. Yeah, I just make sure that all the group have an assignment. That's all. Any more about the assignment first? No, okay. Of course, you you have any question because you still have 2 days, you can be WhatsApp me. Okay, if I late reply to you, then maybe because we have the seminars. I think this week a lot of the seminars were going on. Okay, for the master student, but today is already end. Okay, and then about the second thing is about your final exam. Anything you are not clear? Just now I have mentioned the final exam we will conduct. Final exam will be on the 9th of the February. It's the time is 3 to 6 o'clock. Then you have I will put in the spectrums. Then you download the question similar to what I have done in the test 1 and the test 2. Okay. Any of you have a comment or you want to ask any question?
Just a general question. In right, like this kind of online examination, can I do it in the library, or am I allowed to be on campus, or?
They do not. The first thing is, are you allowed to come to uni or not? If you allowed to come to uni, I think they don't care about where are you conduct your exam. They don't have any restriction on this thing.
Okay.
Yeah, I do not know other courses or the next semester maybe they want to conduct in the face-to-face. I also not very sure. But of course, some of them you may stay in the library. But if they allow you to go in, I'm not sure that whether now the library is open or not. Any of you?
I'm just thinking that sometimes it's not conducive to do examinations in my home.
Yeah.
So yeah. So I was wondering if I can go to the library to do it or something.
Yeah, even though I think the ISM, our department also, in fact, is the reading room is open.
Reading room?
Yeah, we have a reading room at the downstairs. It's open. But I think the reading room will be the public space. So maybe it's not really suitable.
Okay.
Yeah, but if you are nearby, I think that now they will allow you to visit the department. Then you can become.
Okay, thank you.
I believe that a lot of you still you just finish out your presentation today or yesterday. Okay, maybe you're not ready for your final exam first, but I just tell you about the time, and then I show you some examples. What are the things we will ask you? In fact, it's all, but I just show you what is the question they look like. Okay, if some of the question I've given you the equation, then you just formulate it. You just tell me whether this equation is lead you to the maximum or minimum. Okay, or I've given you the fractional without the data. Then you need to answer about the what is meaning by restoration. Okay, the basic concept on all these things. Okay, if the data is given, then you need to complete the tables, or you just complete a few of the values in the tables. It's not the complete set. Okay, yeah.
Hello, hi doctor.
Hello, hi, yeah.
Can I ask you a
Yeah.
question? Are you going to let us know our total continuous assessment marks later on?
No, I will given you the grade.
I see. Okay.
Yeah,
Thank you.
yeah. Mm. Any more question?
Doctor.
Yeah.
Never mind. You go first. You go first.
Okay. Who is it? Want to go first? Yeah, I think the who is it? Lei is it just now? Or Ding?
I think it's Chen Jiaye.
Oh, Chan Jie. Okay. Yeah, Chan Jie.
Sorry. I will
Okay.
ask her, can we use Google Translate if we can online?
Google Translate.
Yeah, because reading the question is hard to me.
But why you need the Google Translate? Is it you want to write your answer in the Google Translate?
No. Because sometimes the word.
That one is up to you. That one is up to you. But
okay,
because once I give you the exam question, you want to translate, then it's up to you. But I do not think that you translate, you will get the correct meaning, unless that one is a language, because sometimes they give you the different meaning.
Yeah, I understand. Yeah, just need to check some meaning of the words.
Yeah, because I don't use that one is called what? That is a one system one. RUM, you have the portering system. I don't use a portering system. Therefore, yeah, you can do that.
Okay, yeah.
Yeah, another one, Ding, is it?
Yeah. Doctor, I want to ask for the regression model, right? Because in the reference book itself, they also have a regression model for the Anova, blocking, and factorial design. So will that be included in the final exam as well?
No, you just cover those of them. I teach it to you. In fact, I need the regression model is I show you is how to get the quadratic equation. The quadratic equation, then you may need that one. But if you just the factorial design, the 2 power k factorial design, that one you already get the effect divided by 2.
Oh, okay.
So you no need to go, because if otherwise it will involve many things in the regression.
Okay. Okay. Thank you, doctor.